transcription's being done, before we even hit the what? The last thing. Termination sequence. The ribosome can assemble and find the start codon and begin translation. This can happen in a euc since the location for transcription and translation are not in the same site. Can't happen. Therefore, probes can make proteins much more quickly than eucs. So that's the location part. There's 3 parts to this question. That's the location part. In a euc, they happen in a different location, and then I went into detail. In a euc, the DNA is located in the nucleus, and the ribosomes are located in the cytoplasm. So it is not possible for transcription and translation to happen at the same time. Because there's a separation of location, this takes longer, blah, blah, blah. Transcription in the nucleus and translation happen in the cytoplasm. Also, the reason that things are more complex in the euc is because of introns and exons. When we sequence euc DNA, we find that there are large pieces of DNA that do not do what?
Code anything.
We can call these non-coding sections introns. Introns are non-coding sections of DNA. Exons are coding sections of DNA. During transcription, we have a direct copy of the DNA into RNA. We have to get rid of the introns.
Oh, yeah.
So eucs have to what?
Restriction endonuclease.
There's a word that she likes.
Scissors, slicing.
Slice. We have to splice the introns out
Using RE?
using endonuclease and stick the exons together. That all happens where?
Transcription.
And this happens before mRNA.
Also, it's before, so it's in replication.
This all happens before mRNA leaves the nucleus.
So it's in transcription.
Remember, I don't know who it was, we were talking about why your children would still have exons and introns because you got rid of them. It's because this happens before you. I don't remember who it was. Somebody was talking to me about.
This doesn't happen in DNA replication, though, right? Just from DNA going to mRNA.
Yeah.
Right. Yeah.
Because they're passed on. So
Right.
This is
Right. Yeah.
happening in transcription, not
Yeah.
replication.
Yeah, okay.
Yeah, because it does get passed on to your kids.
Yeah.
So this is an extra processing step that happens in the eucs that probes do not have to do. So it expedites them quicker. The last factor is operons. Operons are a factor in why probes can respond faster than eucs. Remember that an operon is several genes under the control of what? One promoter. If the probe cell needs to digest lactose, RNA polymerase binds to? If a probe cell needs to digest lactose, RNA polymerase binds to the promoter and transcribes all the genes for those enzymes together. But in a euc, each gene has its own promoter. And the genes that are used together aren't necessarily located near each other on the chromosome. So those are the 3 things. Then somebody wanted to go over number 9?
We need a lot more detail on that than I did.
Into this one?
Yeah, it's just more detail than I have before.
See, I literally wrote, I'm giving you some bits to get you started. So, this is Dr. Igo's words. This is how you can tell I typed her. This is her talking. I'm giving you some bits that you can get you started. Hopefully this gets the juices flowing. This is like proof that you listen and you type. Remember I told you guys when she starts talking about the lecture questions?
Yeah.
You stop your lecture, you open up a Word document, and you type. You've been doing that, right?
Sure.
Like Taylor has over here.
That's true.
No, but that's why these are all typed up. I had a Word document open, I would listen to the lecture, she'd start talking about an essay question, I'd start typing.
I can't split my focus. I just type
No,
notes
she doesn't
and then
say
I
I'm
go
going to
back.
start talking about an essay question.
That'd be awesome.
She
But
should.
remember, no, what are we talking about? Genesis knows. How do you start studying for a test? It's a brand new unit, first lecture.
You listen to lectures without taking notes first.
No.
Read that.
Oh, you read all the essay questions and keep them fresh in your mind. And
So then when it comes up, you're like, stop, type. Okay, number 9. Who wanted number 9? All of us. Okay.
We want 9.
9 is, I love number 9. I didn't get number 9, but I like it. Okay. Analyze the rise of antibiotic-resistant infections, including how bacteria become resistant, how someone gets a resistant superinfection, and how society encourages the development of these resistances. Okay. So how they become resistant. You want to just read mine, or does somebody want to chime in? mutations, and then in parentheses, natural selection, evolution. Random mutations, bacteria find a way through random mutations to survive better in their environment. The first bacteria who evolved a resistance then passed it on to another bacteria cell, which passed it on its DNA through transduction, conjugation, transformation. They get drug-resistant genes. Then my steps are the reasons. One of them is that we use old drugs before switching to new drugs. So this is just an explanation. What that means is if we have a new bacteria, a new strain of, like, let's say some kind of cold, but your doctors are still giving you some old medication, it's not going to help. So using old drugs before switching to new drugs. In the body, antibiotics kill sensitive bacteria, but not resistant bacteria. In a hospital, pathogens become resistant. They're exposed to antibiotics. In livestock, antibiotics in livestock feed goes into the soil.
What about the hospital?
The hospital pathogens become resistant because they're exposed to antibiotics.
What did you say before hospital?
In the body, antibiotics kill sensitive bacteria, but not resistant bacteria. In livestock, so we have body, hospital, livestock. In the livestock, antibiotics and livestock feed meaning, the food they eat, goes into soil, and now the soil bacteria have multiple drug resistance, and that goes into the water.
Oh.
Oh, that's right, I didn't finish. Hold on,
Yeah.
No, I'm just gonna go over it.
Okay. And then inappropriate prescriptions. If you get a cold, it's not a bacterial infection. It's an upper respiratory tract infection. It's a viral infection. So your doctor's giving you antibiotics for something with the virus. And inappropriate usage of prescriptions. Not completing our prescription. Stopping treatment early. This is on this page when she starts talking about it. So that's what I took notes on. That's it. And then to go into the superinfection, you got the points, right? The superinfection, how someone gets an antibiotic-resistant superinfection, damage to the microflora. Flora damage can lead to superinfections that could also be antibiotic resistant. Flora prevent infection by pathogens. They compete with pathogens as well as specifically make chemicals to kill pathogens. So that's their job in your stomach, in your body.
Superinfection is?
A superinfection is something you get where it's killed off the
flora.
It's killed off the flora, but it's also killed off the fact that because you're using medication, or you've used medication in the past, you've killed up all the little baby bacteria that weren't that strong, and now all that's left is these resistant bacteria inside you, and no matter what they give you, nothing's going to kill them.
So what's killed the flora? The antibiotics, right?
Yeah.
Okay.
So
Misuse of.
a superinfection is you've used antibiotics to treat, and all it's done is treat sensitive bacteria and also create an imbalance in your
Yeah, because
flora,
what
and now you're left with really strong super resistant bacteria that just continue to make you sick?
Right, because you're giving you medication that's not potent enough. They're giving you a small dosage.
Mm-hmm.
So this is what I wrote. Using potent, very effective and small doses of antibiotics with broad spectrums. That's one of the words that she uses. Broad spectrums. Remember you guys did the whole drug thing. There was broad spectrum. Yeah. That can hurt our flora. Example: tetracycline, chloramphenicol, and quinolines. It leaves us open to superinfections brought on by damage to the flora. It kills off our flora and sensitive pathogens. Resistant pathogens then survive and are left to grow and multiply and cause a new infection, which is a superinfection. I'm going to read that again.
I got it.
Okay. The superinfections are brought on by treatment with antibiotics that kill off the flora. Now, to kill the superinfection, we'll need a different antibiotic.
Right.
Everybody got that?
And we're running out.
We're going to eventually run out of antibiotics. But things come up. Nature makes things. Like, I just learned when I went on this trip, how everybody's freaking out about the landfills and blah, blah, blah. Well, nature evolved